For the 44th problem on the second ACT practice test, for the triangles in the figure below, which of the following ratios of side lengths is equivalent to the ratio of the perimeter of triangle ABC to the perimeter of triangle DAB? So just looking at these triangles, what you can notice is that they have the same angles within them. So let's look at this triangle ABC. You can see up here it's got a 60-degree angle, and here it has a 90-degree angle. And we know that the sum of the angles in a triangle add up to 180 degrees. So 60 plus 90 gives us 150, which means that this angle here would have to be 30, so that all of these three angles add up to 180 degrees. And looking at this bigger triangle, DAB, you can make the same conclusion, but for this angle down here, since this is a right angle here, so 90 degrees, this is a 30-degree angle, 90 plus 30 gives you 120, and the difference between 180 and 120 is 60. So this angle right here, we know is 60 degrees. So in conclusion, both of these triangles are 30, 60, 90 right triangles. Or in other words, since they have the same angles within them, we know that these two triangles are similar to each other. So let's take a closer look at a simple example of similar triangles, just so that we can better understand their properties. So let me make a quick sketch of two similar triangles. So here we have these two triangles, and I claim they're similar to each other. So all of their angles, their corresponding angles, are equal. So for instance, this angle here would be the same thing as this angle here, whereas this angle on the bottom right would be equal to this angle on the bottom right. And another way that you can tell that they're similar to each other is that all of their side lengths are in proportion. So this side length here, 3, is in proportion with this side length here, 6. And 4 and 8 are in proportion as well. So in other words, we start with this triangle here and we multiply the same number to each of these sides to get the corresponding sides on the bigger triangle. Notice that 3 times 2 gives you 6, and 5 times 2 gives you 10, and 4 times 2 gives you 8. So that's another way to know that these two triangles are similar to each other. If all of their corresponding angles are the same, then their sides will be in proportion to each other. So for this problem, we're looking at the ratio of the perimeter of triangle ABC to the perimeter of triangle DAB. So we're thinking in terms of perimeters. Now, let's see what happens to the perimeters of each of these triangles and how they relate to each other. So we'll call this triangle 1, and this one here can be triangle 2. So for triangle 1, its perimeter is just 3 plus 4 plus 5, which is 12. And for triangle 2, our perimeter is 6 plus 8 plus 10, which if you add these all together, you get 24. And the key takeaway here is to notice that the perimeter of this bigger triangle is in the same proportion as the side lengths to the perimeter of this smaller triangle. Or another way to put it is that this smaller triangle, its perimeter is exactly half of that of the bigger triangle. And this is important because each of these side lengths is half of the corresponding side lengths on this triangle. So what we can conclude is that the ratio of the perimeter of this triangle compared to this triangle is the same as the ratio of, let's say, this side compared to its corresponding side here on the smaller triangle. So going back to our particular problem, let's say that this side length here is 15, and the corresponding side on this triangle would be this side AB, and let's say that that is 5. So essentially, the ratio of the corresponding sides, and just so I make it clear, I'm just making these numbers up, but the ratio of the corresponding sides would be 3. And based on what we noticed with these two similar triangles, we can also conclude that the ratio of the perimeter of this big triangle would be 3 times the perimeter of the smaller triangle. So whatever ratio the side lengths have, these corresponding side lengths, the perimeters would have the exact same ratio. So to answer this question, we're looking at the ratio of the perimeter of the small triangle to the big triangle. So if we were to pick, let's say, this side AB here, we can say that the answer would be that side to its bigger side, or its corresponding side, which would be this DA or AD. Since, like I said, the ratio of the perimeters would be the exact same ratio as the ratio of the corresponding sides. So this side here would be in proportion to this side here, and that proportion would be the exact same as the proportion between the smaller perimeter to the big perimeter. And you can notice that AB to AD, this is actually one of the answer choices. So choice F is our final answer. But you could have also done it with, let's say, this side BC and its corresponding side on the big triangle, which is actually AB. So BC to AB would be a correct answer as well, though you don't see that in the choices. And the final option is to take the hypotenuse of the small triangle, AC, and that would be in proportion to the hypotenuse of the big triangle, which is this BD. So any of these ratios would be the exact same ratio as the perimeter of the small triangle to the perimeter of the big triangle.